Good morning and good afternoon, everyone. I'd like to welcome you to today's webinar, Enforcement and Containment with Segmentation, brought to you by Fortinet and Carousel Industries. We are joined by Carousel's own Director of Security Solutions, Josh King, and Vice President of Managed and InfoSec Solutions, Mark Moretti. Josh, the floor is yours.
Thanks very much, David. Thanks everyone for joining. As David said, today's segment is around enforcement and containment leveraging segmentation, and I'm just going to jump right into it. So why are we talking about segmentation? Isn't this something that we all do today? And the answer is sort of. And what's going on in the industry today, we need to kind of change the way we do segmentation. Well, what are some of those things that are going on in the industry? And I kind of have the obligatory news and statistics, for my first couple of slides. So I think ransomware is really front and center on why we're talking about segmentation again. And reason being is, early 2018, when essentially ransomware moved from being an annoyance to a major security concern and a board level concern, when essentially it changed from affecting one user to having worm-like properties. And once one machine gets infected, it searches out all other machines on your network, just to make a mess. And I have two really good examples of that with City of Atlanta and Maersk. City of Atlanta was an interesting one, and just ransomware is an interesting one in general. Something in the range of $2.6 million. I mean, I think it's probably more than that, but it was $2.6 million. They posted the bill online of incident response and triage and boots on the ground and just trying to get those systems back up and running. And the ransomware, I'm not even going to call them writers, whoever sent the ransomware, only wanted $52,000, in response. So, hey, give me $52,000 or I'm going to cause $3 million in damage. It's just, it's a concept that doesn't really make sense. But it pointed out, in how can this happen? How can we go from, hey, on Wednesday, everything's green, all my machines are up and running, to Thursday, the entire network is down because I have all of these endpoints that are encrypted. Another good example at scale is Maersk, shipping organization, 50,000 endpoints encrypted. And I don't remember the exact statistics on this one, but I think it was, in less than half an hour or something like that, that amount of endpoints were completely encrypted and essentially taken offline. And it caused millions of dollars in damage, again, between response and lack of productivity and reputation. And Maersk, the way they recovered, they actually spent something 10 or 12 days straight recovering all 50,000 endpoints from backup, which is kind of a feat in itself, that they were able to get themselves back online so quickly, and even an even higher testament, to their backup strategy. But it's still, even with that, caused millions of dollars, in damage. So kind of a big deal there, right? And this is kind of what we see, week after week, month after month, where these networks and these organizations are being taken down due to ransomware. So it's kind of the same time as this ransomware is becoming, it's not really becoming a problem, it is a problem, it's just not going away as a problem. At the same time, we also have, some changes, going on in the industry. And a lot of this stuff isn't new to us. One of those being, on-prem data centers versus cloud technology. And if you spoke to some people some years ago, cloud was everything, right? Everything's going to be going to the cloud. On-prem data centers are going away. As we know, nothing is that black and white, in this world. And what, I would say a majority of customers are adopting is a hybrid cloud type of strategy, where it's not just, I'm going to put everything in my on-prem data center, I'm going to put everything in my cloud-based services. I'm going to do a mix of both. I'm going to pick the right workloads and services to go to the cloud, and I'm going to keep, the rest back maybe in my on-prem data centers, or maybe a colo facility or something like that. And at the same time as that strategy is, being executed, the number of devices on our networks are not, getting any smaller, right? So the projection by 2020 is somewhere in the range of 20 billion devices or 50 billion devices. I don't know. It's some insane billions of devices. The projections are probably low at this point, and it's probably going to be a lot higher than what is projected, right? So now we have our data and our services and our applications and all these different locations, and the types and number of devices accessing that data, is kind of getting out of hand at the same time. So lots going on there. And then, when we look at it just from a raw security incident standpoint, the timing of things, right? So it takes minutes in most cases to compromise an environment. So if I'm thinking about ransomware, someone gets an email, there's a link in it, they click the link, some malware gets downloaded, bing, bang, boom, now they have ransomware, right? So that could be minutes to compromise. On the flip side, if we're not talking about ransomware, which is, by the way, is very loud and in our faces about it, if we're talking about the low and slow attackers, the ones that are really interested in your, in your critical data sets, it could take months to uncover that a breach has actually occurred. So, we kind of need to keep all of this in perspective as we're starting to think about all the technologies we might want to use in this case, and then cue in segmentation. And the first thing, when I talk about segmentation, well, we're already doing segmentation, and in a way, yeah, a lot of us are actually doing segmentation. So maybe a quick history lesson, very simple one, and kind of, by the way, I like to, when I talk about this stuff, I like to use an analogy of our networks being an office building, just to kind of give us some kind of physical, pictures in our brain when we're talking about this stuff. So, the way we used to do it was everything was on VLAN, right? VLAN 1. All my users, essentially, they're in a single conference room with a single way out, to the internet. Maybe it's a firewall. If you go back farther enough, maybe there wasn't firewalls. It was just, NAT even, right? But the general idea is, it's really easy. It's really easy to put everything on VLAN 1. I don't have to worry about addressing and segments, and it's just everything's on the same. I don't worry about routing. Okay, great. That's wonderful. But oh, by the way, the world was much different back then, right? It was safer, so I could put everything on VLAN 1. Well, the number of customers that we run into these days that have a flat network in terms of one or very few VLANs is kind of few and far between. There's usually probably a handful of segments, these days. So when I think about the flat networks of today, it looks something like this. So continuing on that that office building methodology, it's not everyone's in one conference room or one VLAN. We have several conference rooms and several VLANs, and what we do is we assign a type. Users go in this room. We got IP phones, we have servers, and maybe we have remote sites, and so we kind of segment them the way we think they should, and then we try and put those users and devices into those segments, as necessary. So the problem with that kind of methodology, just thinking about it from an office building, right? If I've got conference rooms, I have 6 conference rooms, and let's say I have 20 people in each. Well, the problem with this type of methodology is there's really nothing stopping from users to just getting up from their chair and walking down the hall, and go and see in the server room, or users to other remote sites, or users to users, or users to the internet. Typically we allow everything out to the internet. Or we have remote sites that maybe have less physical security, just getting up and going to our server network. So that's really, when I talk about flat networks of today, it's not that we're not using VLANs and we're not segmenting them. It's that we have no security controls between those segments, right? And at any given time, there's hundreds, if not thousands, if not hundreds of thousands of connections moving through our environment. So whether that's north-south, from inside the network to outside, or whether it's east-west, and that's internal segment to internal segment. And the problem we run into is that, on these green lines, these north-south lines, you can, if you're going to a known bad website or you're clicking a malicious link and you're downloading malware, you can get something bad pushed to your machine. But then because we have no secure segmentation via those blue lines, we can be spreading that around our environment. And what that really leads to is the Maersk in the city of Atlanta. Once one machine gets infected, now all machines get infected. So one machine gets infected, he infects everyone in that segment, and then that machine looks for all other segments in the RFC 1918 range until it finds and infects as many machines as it can. And that's why we're constantly seeing on the news, probably weekly, networks being taken down, from ransomware. So thinking about this, in order to help us, solve this problem, we need to look at more secure ways of doing segmentation. As we said, we're already doing segmentation. What about secure segmentation? Now, there's some challenges with adopting secure segmentation, some problems, right? So number one is maybe our infrastructure doesn't support the type of features and technologies we need in order to do segmentation, right? So the switches and the routers and the wireless components need to support that. How about limited visibility and understanding of the current environment? If I run the network side of things, I'm responsible for route switch, wireless, maybe even the firewalls, right? But a lot of times, do we fully understand all the applications and all the dependencies and what clients access what servers on what ports, to and fro what, so, understanding the environment can be a stumbling block to doing secure segmentation because you don't want to break things, right? And then let's say we have those segments. How about getting the users into those segments? So we have this problem today where I've created 3, 4, 5, 6 different VLANs, but how do I make sure that the devices and the users accessing or going into those VLANs actually should be there, right? So, and then adding additional segments adds management complexity, right? So we have to think, a lot of times when we say, well, I'm going to segment that, I need more segmentation granularity, I'm going to add 20 VLANs or 10 VLANs, right? And that can get out of hand really quickly. From a design complexity and a management complexity, that can be a challenge. And then support across the silos, right? So when we're talking about segmentation, whether it's on the edge, whether it's in the data center, I might have a couple different teams depending on the size of my organization. So I might have a server team, security team, application team, desktop team, right? So those different groups may need to play together, in order to actually see this thing through to success. So visibility is one problem, right? I need to understand what's there. And then let's say, I start to go down the path, but I never graduate to enforcement mode, meaning I have the visibility, but I never actually block anything. Or the flip side, I actually turn the blocking on, but because of maybe my lack of visibility or my understanding of the environment, once I go live, I end up with help desk calls, which eventually lead to, whitelisting mayhem or the Swiss cheese firewall effect, where I've blocked it as much as I could, but then I had to open up so many ports because things were broken, I might as well have not have started to do this to begin with, right? So that's a concern there. So if we can get through that, there's some benefits here, some real benefits of doing segmentation correctly and securely. The big one to me is slowing down attackers. Limit or eliminate the threat of lateral spread. So when we talk about City of Atlanta, Maersk, or any organization that was taken down by ransomware, the problem was that once that one machine got infected, all other machines were now fair game. Unless there was some type of firewall, between other users and that device, there's really no way to stop that, right? So adopting a stricter level of segmentation helps us there. Another one that I really like is compensating controls, right? So how do I protect vulnerable assets when patching is not an option, right? So let's say the new WannaCry comes out, and the vulnerability for WannaCry comes out, and there's an exploit for it and everything. Let's say I have a great patch management strategy on both my endpoint and my server. But what if I have 100 workloads, 300 workloads, 1,000 workloads in my data center? Even if I had a great patch management strategy, I can only do that so fast and so quickly. because I have, emergency change control. If it's, servicing customers, I just can't bring all that stuff down, right? So there's going to be a length of time in between when I know about the vulnerability and when I can actually patch it. So by adopting a more secure level of segmentation and adding in kind of advanced inspections, which we'll talk about in a later slide, I might be able to protect that endpoint before it has a chance to protect itself with patching. The other thing would be easier containment, right? So if we're doing segmentation to just give us a better steady state level of security, when something does happen, I already have the enforcement points in place to contain that that malicious source, source, or block those destinations or whatever it may be. It helps us get to the policy of least privilege, but then enhances our incident response capabilities. So lots of benefits here. So which brings us to, there's really two ways of doing it, macro and micro-based segmentation, and we're gonna start with the edge first, right? So in a way, we're doing some macro-based segmentation on the edge today. It's our edge firewall to the internet. It's protecting all of our internal segments against the untrusted internet, right? And the nice thing about that edge firewall today is that it's typically a next-generation firewall. More often than not in 2018, and that feature set affords us certain type of capabilities and features, right? So more security in less devices. So intrusion prevention, antivirus and malware scanning, application awareness, identity, URL filtering, reputation, etc. Typically, we have a default deny from the outside. I think where maybe a problem is that a lot of us still have permit. Once you're inside the castle there, once you're inside the office building, you're allowed to go out whenever you want, right? So all ports, and so on. And then the other kind of, I think, power of that next-gen firewall today is the enhanced logging and reporting capabilities. So the visibility, and I say it a lot in this presentation, just, you can't secure what you can't see. So knowing what is there helps us. Now, there's some ways we can enhance this right out of the gate, right? So there's always room here. And as I said, most customers I've seen have some type of next-gen firewall at their edge today. Not all, and most that don't have a plan to get there. But the point is, there's a lot of feature set under the covers, and we want to make sure we're taking advantage of it, right? We want to lock that door a little bit tighter than we do today. So all inspection policies, we want to enable whenever we can. Outbound filtering where possible. Not all of your endpoints should be able to access the internet on all ports. It's not needed. There's a lot of noise ports that we can probably close. Most tools have geo-blocking and IP reputation-based services today, right? So, for example, if I have external-facing services and I know that I don't have customers in certain geographic regions, maybe I can just block those right out of the gate. Now, is it going to prevent, all incidents from occurring? No, because if I'm clever, then I would just piggyback off of, an asset in United States to attack, your external-facing service, right? The idea is to limit the number of potential attacks, though, by using this. Leverage the capabilities of these tools, right? So the TopX, the logging, that's how you understand what's normal in your environment. But if you're not kind of taking advantage of that, then you're not really going to have that intelligence data. Integration with Active Directory, and the big thing to me there is getting user identity instead of IP addresses, right? So when I'm talking about incident response and, the tools we put in place, like our next-gen firewalls, they flag some type of event, they see something. Okay, well, how long is it going to take for me to understand and drill down what's actually happening? The more data I can have in those logs, the better. So what's kind of the next step here, right? So let's think about protecting our critical assets. And typically, those are in our server environments, right? So how about taking the same approach that we do to protecting all our internal assets from the internet and protecting our servers from our internal assets? And what I'm talking about here is a data center next-generation firewall. So placing a next-generation firewall in front of my server segments. Now, depending on your data center, your cloud makeup, this may or may not make sense, depending, right? But the general idea is some low-hanging fruit. Even if I just put this next-generation firewall in front of my server VLANs and enable my inspection profiles, I can dramatically enhance the security of my servers from, infected users and devices, on the rest of my network, right? Because I might have intrusion prevention or I might have malware scanning enabled, where I was talking about compensating controls earlier, where if I can't patch quick enough, if I put an IPS in front of my servers, maybe that's my way of protecting those servers in the meantime. The other kind of way here, closing unneeded ports, right? So if I have a web server, I might need 80 and 443 open, then why do I need the other 65,533 ports open, right? I probably don't. So I can use this mechanism to reduce the attack surface, of my server environment. So the big thing here is I'm not only reducing the attack surface, but I'm also limiting lateral spread from my user endpoints, right? And I've kind of said that already, where if I have that firewall there and I'm using, so I have less ports open, and then I'm concentrating more security on those less ports. So now the likelihood is less that a compromised endpoint will take advantage of my server environment. And the next-gen firewalls of today grant us and afford us ways of simplifying our rule sets with group mapping. We talked about Active Directory instead of doing IP addressing, and it brings us a lot of capabilities there, right? So the idea is now we're starting to lock those doors and make it a little bit more difficult, for endpoints to get in there. So moving on, so we protected our servers, by putting a kind of a macro-based firewall in front of both server segments. We haven't stopped, servers talking to other servers, right? But we've protected servers from endpoints. The next piece is how do we protect all our assets on the edge, right? So how do I protect all my users? And I do that with edge-based microsegmentation. So the general idea here is I want to put an enforcement point in front of all users and devices, individually even. And the coverage should extend to, wired in, wireless, and any, external access into my environment. But the general idea is that by adding that enforcement point, I'm adding at least a port-based firewall. And we're going to talk about some of the technologies that help, get us there. Because, like I said, the point being, if I put a firewall at my segments, let's say I put a firewall in front of all, both user segments, my IP phone segment, at every remote site, I still haven't protected user to user in those same segments, right? So that's really where this comes into play. And the benefits to this, like I said, we're limiting lateral spread now between all endpoints. We're reducing the attack surface of all assets. My favorite one, I think, is I'm adding security to devices that have no security. One of my favorite use cases is printers. In 2018, they're still awful. We still struggle with them. They come with web servers that, they have too many vulnerabilities. They're never updated. And we actually had a really nice customer use case for microsegmentation at the edge at a very small level via printers. They had 400 printers, and they had recently done a vulnerability scan, and some critical vulnerabilities popped up for those web servers. So the fix was to update all 400 printers' web servers. And there were some physical level problems. You had to kind of load it via, it was some obscene process, and I don't remember the full details, but essentially it just wasn't very doable. And it would, even if they did do it, it would monopolize a lot of people's time for a while. So what we did was, and we're going to talk a little bit more about this, is that the customer had network access control. So we decided that, okay, well, when you're identified as a printer, we're going to push down an access list to the port. There's our enforcement point that says, this machine can only be spoken to from user segments on the printer port, not port 80. And then we let the printer talk to the print servers, and we let the printer be accessed from admin networks, but not from other users. So now I've completely eliminated the vulnerability in the web server, and now I don't have to visit 400 printers to update the web server. So that's kind of a real-life use case, and that's kind of where I really like the idea of this, because I can add security to devices that have no security. It also, by the way, gives me containment for quick incident response. So even if let's say I have this in place today, and I have all these enforcement points in my policies, and well, they might be heavy-handed, they might not, but if an incident does occur, I have all the policies in place already. The ability for me to kind of jump into a system and quarantine a user or kick them off the network so they can't do any more damage, it's going to be a lot easier for me to do that with all the infrastructure already in place. So in order to do some of that, I need some specifics here. There's some technology and feature set that I need in order to do this segmentation at the edge. And there's some things that I need. So like I said, number one, I need to observe traffic flows on my network. So we talked, I kind of showed the green and blue lines, north, south, east, west. How am I going to understand what devices and endpoints are accessing today so that I can make policy for what they should or should not be able to access, right? So I need that visibility into that. From the endpoints that I see, I need to be able to identify users and devices on my network, whether it's wired or wireless. Should you be on my environment? What type of device are you? And once I cover your identity, how about I assess the posture of that device? Does it meet security compliance for my organization? Does it have the right patches, endpoint security software, et cetera? Once I perform that assessment and I have your identity, I need to be able to authorize and grant you access to the environment. All right, this is your level of access. And then I have to actually enforce it, right? So I need enforcement points, as I mentioned before, all over the environment, right? So I need these key kind of features. And at the edge, unfortunately, there is no one solution to help us there, right? So we're going to need a couple different solutions. And I would say the big one has nothing to do with security at all, but it's your infrastructure. So when we're talking about edge-based segmentation, there are certain features I need at the infrastructure level. So if I'm talking about network access control via 802.1x, maybe that, do my switches support 802.1x? Maybe they do it for authentication, but 802.1x comes with certain features that not all switches and versions support. Does it do multi-host? Does it allow for downloadable ACLs? Does it allow me to change different VLANs via 802.1x? So those are some of the features I need. Well, what if I'm not doing 802.1x? How about just pushing a port-based access list, a layer 3 access list on a layer 2 port down to my switches? Can I do that? What about NetFlow? We talked about visibility. That's all up to the switches and the wireless controllers and the routers to give me NetFlow, right? Is it NetFlow? Is it JFlow, SFlow? Is it sampled versus not? That's very important when I'm trying to build an application dependency mapping. Now, what's going to use those features is NAC, is Network Access Control, right? Because NAC is sort of the brains of the operation when it comes to segmentation at the edge. Because as we said, some of the features I need to authenticate the user and device, and that's where NAC comes into play. It's looking at my wired and wireless networks. Friend or foe, should you be on my network? Yes, you should. Okay, what kind of device are you? You're a Windows asset, you're a mobile device, you're a printer. I need to classify that asset, and then I need to authorize and enforce. And it's going to enforce via that infrastructure in those features I just mentioned. Either I'm going to enforce with VLAN changes or 802.1x or port-based ACLs or whatever it may be, right? So network access control is kind of the brains when it comes to this stuff. The next piece, if we're talking, maybe I'm not ready to do micro-segmentation, but, I want to protect my endpoints, and we talked about this already, right? The next generation firewall. Intrusion prevention to help to protect against attacks, trying to take advantage of vulnerabilities, AV and malware scanning to protect us against the files themselves, and then all that logging and, identity information that I get from that firewall. And like I said, we're already doing this today on the edge. Let's push that over to my server networks. NetFlow and flow analyzer. So okay, my switches can do NetFlow, but if I can't send it anywhere to collate and give me my top X and start looking at baselines, it's not going to be any good to me. So in some cases, I might need a separate tool in order to collect that NetFlow, analyze it, and give me some reporting. And with that data, I'm going to be able to start to get a picture of what's normal on my network, what should be accessed, what shouldn't. In addition to NetFlow, we have kind of the syslog side of things. Syslog aggregation, SIM tools, all of these different device types generate lots and lots of logs. And I can get a lot of intelligence and visibility if I actually look at those logs, right? But if I don't have a tool to send it to, then they're kind of just sitting local on the device and will eventually be overwritten by new stuff. So getting a little more detail here. So how can NAC help us, right? So network, and we talked about some of the high-level features of network access control, but one of the big ones is bring visibility to the faceless endpoints, right? So it's not an accident that I use these kind of faceless users to represent my endpoint. Well, they're actually faceless and neckless here. We got hovering heads. Little freaky, but point taken is that I don't know really what they are, right? Without a tool like NAC, I don't know what those devices actually are. So I start to see, like if you look in the guest network, okay, they were faceless. Now I see that I got some tablets, I got a couple laptops in there, maybe some mobile devices. And not just that, but if we think about it, if we go back to our office building mentality, right? And we tend to focus, okay, I got my firewall in place, and then maybe I put a firewall in front of my servers. I get all this great security internally, but we forget about the physical layer, right? If I don't have good physical layer, then someone can, walk into a conference room and plug into a switch port. In our office building analogy, think of that as being, hey, I got that sweet front door with the security guard and the key card scanner and the retina scan and the man trap, but every conference room has a direct door to the outside world and it's not locked, right? So what good is that front security if someone can just walk up, right? So the other piece of NAC is I'm going to close and lock all of those physical layers, right? So I can do that friend or foe. Only authorized users, are allowed to actually, oh, there's a free jack, let me plug in. Oh, I don't know who you are, I don't know what you are. Guess what? You're not getting access, right? So that's kind of an area where NAC can help us. And NAC, like I said, once we identify what these devices are, then I can start to perform my enforcement. And one of the things we tend to see when we deploy NAC for the first time, so if you look at the IP phone segment, we get some devices that aren't IP phones. It turns out I have a printer in that VLAN, and if you look, that's my little IoT robot man there. I get an IoT device in the IP phone VLAN. Well, unless I have a tool like that, there's no way for me to know for sure that the segments I created actually have the devices that should be there. Right? And like I said before, you can't secure what you can't see. And kind of keeping that mantra, I can't secure what I can't see, now we're going to bring in our logging and our flow analytics capabilities, right? So I need to provide context for that user behavior, right? That context can then give us guides to help us build policy, right? And at the edge, we want to be very simple. We don't want hundreds of rules on our switches. Switches are not firewalls, right? So we want to keep them as small as possible. But that means I need the data in order to help me get there. And what I'm really looking for, right, is I need the visibility. I need the surveillance system in my office building. And I need the surveillance in the hallways, at the front door, in the rooms themselves. I really need that visibility wherever I can get it. Wherever a flow can reside, the more data I have, the easier it is for me to understand what's happening in my environment, the easier it is for me to lock things down so that when someone clicks on something they shouldn't, I can get it to where it needs to be. And this is really what we're looking to see here, right? With that surveillance system, I'm now able to see all north-south traffic, all east-west traffic. I have the context. Maybe I have the user identity data tied to it. I know what's normal. I know what's not normal, right? It's so critical. And I think this is an area that it was probably still up and coming because I think a lot of folks still need tools and solutions like this in the environment. It's just very difficult to get that east-west visibility. All right, so now that we spoke about microsegmentation at the edge, let's talk about microsegmentation in the data center. Because while the problem is the same, how we do it and the tools available are much different. So we still have those faceless endpoints. For the most part, we know that, hey, I deployed this server. It was supposed to be a web server, but do I know if it's still acting like one, right? But where I want to be is I want to have an enforcement point around all my servers and applications as well. And then I want to make sure that I understand what they all are and what they are, what I think they're doing, they are doing, right? Their web servers, their database servers, their sys file shares, whatever it may be. But in the server world, in the application world, it's not quite as easy from a dependency mapping as it is at the edge, and the reason being is the tiering of that architecture, right? So I might have web front-end servers, which then talk to application servers, which then talk to database servers, and I've got 3 of each and load balancers, and it's just difficult to understand. So pulling that back out generically, it looks something like this, where if we're doing microsegmentation in the data center, we're really trying to compartmentalize the different servers and applications, right? So if I have certain servers and applications that only need to talk to each other, I put them in, the blue section here or the green section, but where do they reside? I might have some physical servers still. Maybe it's in my on-prem data center. Maybe it's in the cloud. But maybe it's 1 VLAN. Maybe it's 5 VLANs. But I got to figure out a way for them all to talk to each other. And that just sounds complicated to figure out without a tool or a solution. Breaking it down a little bit further, the way we kind of do it today, or we might do it today, so on the left side of the picture, I decide that, okay, I'm going to make an application VLAN, a database VLAN, and a service management VLAN. And all my app servers go in one segment, and all my databases go in the other, and so on. And, that inside firewall, maybe it's physical, maybe it's virtual. So on the right, the idea is being, well, why don't we start segmenting based on our actual application? So I have an HR group, and they have web front ends, application servers, and databases. I have finance group with DMZ servers and app servers and databases, and that's how I start to do my segmentation. I do it based on who and what these devices are and their purpose in my organization, rather than just because I decided to put them on VLAN 6 or VLAN 10, right? And then I can put security within those segments and between those segments. So blowing it out even further, this is where we're really talking about here, is I might have an HRM production system, and I might have a staging system, but the only devices and endpoints that should ever talk to staging should be production. Or maybe I have PCI, and we know how tight PCI networks need to be. Maybe there's little to no access to the outside world from a PCI perspective. Or between my ordering network. And, we look at this picture, it's totally based on the applications themselves. This could be 2 VLANs or 3 VLANs or physical and virtual or physical, virtual, and cloud. It doesn't really matter. The idea of segmentation that we're talking about is essentially relegate VLANs to IP address assignment only, not security. And that'll be easier for everyone to understand, because I understand that a web server needs to talk to an app server who needs to talk to a database server, right? That is a little bit easier to understand than VLAN 6 to VLAN 7 on these ports and so on and so forth, right? So that's kind of where we're trying to get to, right? And that kind of sounds complicated, by the way. And we need solutions and tools, to help us get there. So, cue in actually the microsegmentation space for the data center. So there are solutions that deal with this problem. And the good news is this, because most of this stuff is in the virtual world with some leftover physical and some cloud, we actually have more capabilities than we do on the edge. So on the edge, I need way more tools, like NEC and infrastructure and firewall, and I need all these extra tools. But in the data center, the tools were designed with everything you need. It's just kind of figuring out which tool makes sense. And there's 2 typical ways of doing this. It's agent-based integration and network-based integration when it comes to microsegmentation in the data center. So the first one, the architecture is as it sounds. Agents are deployed to all your workloads. And when I say workloads, I mean all your servers. So wherever you want to actually do that enforcement, I need to deploy an agent. Now, the benefits of that is I can extend that to my virtual, physical, and cloud workloads. My enforcement options are now my local stateful firewall. So Windows has a local firewall. Linux has IP tables. And a lot of these agent-based tools essentially give you a nice user interface to manage capability that's already inherent in all your workloads, right? It's not really adding a firewall application. It's just taking advantage of what's already there. If I'm local, I can take advantage of encryption options. So, Strong Swan on Linux, the crypto engine on Windows, and I think the other kind of benefit here is process awareness. that I don't need to do deep packet inspection anymore because I can see the process that's actually requesting the traffic. So some pros to this, right? Bare metal and cloud are now within my sphere of enforcement. I'm hypervisor agnostic, right? I'm on the workload. It could be physical, could be VMware, Zen, Hyper-V, could be AWS, Azure, Google Cloud, IBM, doesn't really matter, right? I can put the agent wherever there is a workload. Could be easy drop-in, right? If I have 300 workloads and I have 10 PCI workloads, and my main use case right now is just to protect the 10 workloads, cool. I can actually deploy the agent just to those 10 machines, and now I've kind of checked off the box, right? Performance, because I'm not adding on enforcement points to my hosts, I'm just adding them onto the workloads themselves. Now the cons are also the pros, so number one, agents. People don't like agents on their workload sometimes, right? So, oh, here's yet another agent. That might be a tough sell, to some folks. If it's an agent, I need certain OS support, so there might be certain OSs that are not supported, so that's a concern. And because I'm an agent on a workload and my security is essentially workload specific, I might not have advanced inspection, capabilities there. So on the network side, the network is exactly as it sounds. So it's a virtual network integration. So specifically, so like a VMware vSwitch type of thing, where my enforcement points will be deployed per host. Essentially it's a next generation firewall like enforcement point. And in some points, depending on the situation you're in, it might be a virtual version of your next generation firewall. And what's happening is that you're doing workload bridging, meaning I might all be on the same VLAN, but to get to that workload that's sitting right next to me in the virtual world, I have to go through this virtual firewall. Because I'm a firewall, VM essentially, deep packet inspection is an option, and because I'm an external, I'm not workload specific, there might be some advanced inspection options that I can use. So advanced inspection options would be like maybe intrusion prevention or malware scanning or something like that. So the pros are that there are no agents, right? So to get visibility in an agent world, I have to deploy the agent to all the workloads I want to see, right? So if I'm thinking about just from a POC standpoint, in the network world, I could deploy an enforcement point to all my VM hosts, but not put any of my production traffic through it, but I could tap it. So it's kind of like span in the physical world, and I can actually see all that data, right? So now I start to build that huge database of what's normal and what's not normal in my environment. Now the cons, again, are also the pros. So I'm hypervisor dependent. If I'm talking about capabilities there, typically a lot of this in the VM world is VMware. Resource utilization, could be an issue. So if I'm doing a lot of advanced inspection, I might be able to do 20 VMs on a host. Now I might only be able to do 15. So that might mean I need to increase the number of hosts I have. Most of the network integration providers actually have hooks into the cloud. I probably should have put that in the pro side, but there's a lot of integration with Azure and AWS and so on to get some of this native as well. I have in the cons here, so external enforcement point for bare metal, and it's not really a con, that's almost a pro. Where a lot of us still have, these handful of physical devices that I just can't get rid of yet. So how do I take almost a VMware-focused, cloud-focused platform and enforce policy, at the physical layer? So some of the providers are doing physical enforcement points. It's not really a con. It's really a con more because not everyone is doing that, right? So again, what are your requirements, and am I choosing the right platform to help get me there? So regardless of what solution you're going to go with here, there's some things you're going to get. So granular visibility. So as I said, on the edge side, getting that visibility is key, and you need all these extra solutions. Most of it in the microsegmentation space, the visibility is there, right? I need the visibility for the sake of visibility, number one, what's happening. Number two, the tool can help us with policy recommendations and can help build the application dependency mapping that we need in order to say that, yep, these server types and these workload types are allowed to talk to these other server types on these ports and so on. and where a lot of these tools are going is to almost automate that process for you. Here's what I saw. Here's what I think you should deploy. Do you approve or do you not approve? Which is clever. And then kind of the analytical look and the visual look at that. I kind of had a couple screenshots up earlier where you can visualize some of this access, to make it easy for you to understand what's happening. Now, some of the advanced features of these solutions depend completely on what solution and vendor you go with. So some of those advanced inspections I was speaking of, intrusion prevention, malware scanning, file integrity, process awareness. Some of the providers are adding in deception-based technology, so the old honeypot kind of idea where I spin up legitimate looking services and that no legitimate user will ever access. So I know if someone accesses it, they are probably malicious and looking to do bad things in my environment. Encryption capabilities, incident response enhancements, or vulnerability analytics. This is an interesting one where you can ingest vulnerability data so that, we're talking about servers, maybe I can't patch them, but maybe there's a policy I can push to limit the risk of that vulnerability since I won't be able to patch. Whether I have a firewall at the edge or, whether I'm just using the workload-based, security capabilities. So there's kind of a lot of features here. So just kind of starting to wrap it up a little bit where I want to show just kind of a visual step-by-step when we're talking about, enforcement and containment, leveraging the things we're talking about. Because we've been talking about segmentation like, hey, let's protect all my assets before a bad thing happens. So let's assume for a second that the bad thing, has already happened. And my endpoint is infected with ransomware. And apologies for some of the text running together here on the slide. So first things first, your endpoint gets ransomware. One of the things they're going to do is they're going to go north, south, east, west. And we've kind of talked about this, right? So they're going to try and talk to their command and control system and then infect other machines in the environment. So our first line of defense there is that next generation firewall at my internet perimeter. Maybe I'm also doing web security, I have a proxy, or I might have a couple layers there, and that's going to be my first line of defense. Now, if I've moved forward and did some macro-based firewalling in front of my server networks, or I'm doing micro-segmentation with my network access control tool, that endpoint trying to reach out and infect other systems might get blocked. Now, let's say for a second I actually do block those flows that we're talking about here. Well, guess what? That endpoint doesn't know any better. He's a zombie, so he's going to continue to look around the network and find someone to infect, right? So we want to detect that, and at some point we want to contain it exclusively, right? So we've limited the risk by performing the segmentation that we have and the, instituting the security controls that we have. But I want to do something more, right? And the next kind of piece of this is how can I send alert data from maybe my next-gen firewall, from my NetFlow tools, from my SIM tools, and actually talk to maybe my network access control and push a NAC action. Actually do have a dynamic containment policy where my network access control tool actually quarantines that user. So now if, once my multiple tools identify this user as malicious, rather than waiting minutes or hours, maybe it's 2 in the morning, while a human can get the alert and do something with it, I can actually have the tools signal NAC to take an automatic action and, contain that ransomware device, So instead, that's the difference between maybe 1, 2, or 3 devices infected and 1,000 devices, infected, right? Because the tools are going to move much faster than you. And, it's kind of funny because the correlation and the alerting needs to be somewhat sophisticated so that we don't have too many false positives. False positives is usually a major concern when we talk about automation. And once we kind of get that in wrap, because we got to get that under wraps, because the next part of the argument or the counter to that is that, well, I would rather, annoy one user with something that's phony than annoy 1,000 users for 10 days or 50,000 users for 10 days as I recover them all from backup, right? So that's just kind of the world we're in. And this is one piece. Segmentation is kind of one piece of the puzzle and one layer in security. So if we're talking about protecting ourselves from ransomware, we're talking about endpoint security, we're talking about email security and other layers to kind of make up for where I can't ratchet security all the way up, right? Because I always have to keep the user experience in mind. I can't just do everything I want to do when it comes to security. All right. So what are some takeaways here? Let's wrap this up for real this time. So, you know, we're essentially all of this, of what we're talking about, is really just continuing the strategy of defense in depth. Security in layers, that kind of model and methodology is not new. I've been talking about it for 15 years or whatever, and I think now we're just seeing some of the tools and the solutions get to a level of maturity that we can actually do some of the things we've wanted to do, for a really long time. Remember that the segmentation, the methods for segmentations differ whether we're talking edge or versus data center. Now, depending on where you go, I might be able to integrate those two methods, but more often than not, what we're seeing is that it's kind of it's two unique projects, and they don't really blend very well. Remember, segmentation is not just for steady state. We're trying to limit the blast radius of threats while giving us enhanced incident response and containment capabilities. As I said, lots of different solution features in each of the different solutions driven by different requirements, right? So we want to make sure we figure out what your requirements actually are and pick a solution that actually fits, right? And this is edge or data center, and I kind of think the good news here is that some of us have some of the tools I've already talked about. We might even be able to use some of that to do some of this, some of these new concepts. Leverage the tools to help with the dependency mapping. So one of the reasons most of us are not doing this today is because it's impossible, especially in the data center. It would take you eons to build the dependency mapping, and by the time you were ready, if you were doing this manually, to actually roll it out, everything would have changed anyway, right? So a lot of these tools, they do a lot of the heavy lifting for us, right? And that's kind of the idea. We need to leverage the tools so we have any chance of putting this into action. Start with visibility always first, and we advance to enforcement. And this is really no different from other solutions in the security space. Network access control, intrusion prevention systems. We always want to do very comprehensive testing, and we want to see that visibility in action first before I ever go live, right? Because I don't want to do to my users what I'm trying to prevent. That's denial of servicing them, so they can't do their job. Finally, the tools, and this is a big one, all the different types of tools help customers of all different sizes. So if you're thinking, you know what, I'm a huge enterprise shop, I don't know if these will really work with me at scale. Or, hey, I'm just, I'm small business, I'm mid-market, whatever. I don't know if I have the size to invest in any of this stuff. And the answer is there's a lot of options there, and I think a lot of these different tools fit different customer size and use cases. And that's kind of why I said it's very important for us to tease out, what those requirements are and connect the dots to the right solutions, because I think a lot of it can help customers of different sizes and different verticals. With that said, that's pretty much all I had. I appreciate everyone kind of tuning in and kind of listening to what we have to say. I didn't see any questions come in. If this is a topic that you would find interesting to continue, maybe a one-on-one specific to your environment, please reach out to your sales team. Let's kind of take this and tailor it more to what your requirements are and what your needs are, and let's see what comes of it. If I'm thinking about a lot of the conversations I'm having lately, or really over the past kind of 6 to 8 months, a lot of it is in the network access control and segmentation arena, because of ransomware and because of some of the legal compliance, and a lot of insurance companies now are saying, hey, I'm not going to renew your policy if you're not doing some of these things. So we would be happy to continue that conversation with you and tailor it more to your organization. So with that said, that's all I had. I appreciate everyone tuning in. If there are any questions, again, reach out to your team and let's keep this going. Thanks everyone for joining.
All right, thank you everyone for joining today's webinar. Please tell us how we did today by using the Rate This function on your screen. Thank you again, and hope you all have a happy holidays.